Good morning, everyone. My name is Amit Shah. I work at AWS. This is my first Xen Summit, but I have been working on Xen for a bit, and KVM as well before that. David and I, David's right here up on the first seat. David and I, we are in the kernel and hypervisors group at AWS, which is the group that runs the entire EC2 fleet, the hypervisors. You've probably heard about that. Today I'm going to be talking about a new feature, a new idea that we have that we've just recently been looking at called LiveUpdate. LiveUpdating the Xen hypervisor, which means you go from a running Xen hypervisor to a new Xen hypervisor on the same system without causing guest disruptions. Guests ideally should just notice some small pause, but otherwise this should be completely transparent to regular guest operations. In a nutshell, that's the idea, and we'll explore bits of the idea in further slides. But first, let me tell you why we would like to have this feature. AWS operates a large fleet of hosts, and we may not get enough opportunities to reboot hosts in the fleet. This could be because of long-running guests or other reasons. And also operationally, we need to be ready to patch the running hypervisor for emergent bug fixes, security events, maintenance events, and so on. Essentially handling issues that may cause customer pain. So rolling out bug fixes, security fixes is standard operation, and that's one of the main focus areas. But we could also have new feature enablement by updating the hypervisor. We could also reduce maintenance burden by reducing the number of hypervisors in the fleet. And also helps development, for quickly prototyping ideas. You know, if you have guest running, which exhibits some bug, you just update the hypervisor live. In a second or two, you have a new hypervisor and you run your test again. That's quite fancy to do in a development setting. So these are some of the reasons why we're looking at this kind of an idea. And certainly there are a couple of other things that we could do, which we do have support for in Xen today. One of them is Lifepatching. Lifepatching works really well. It has been proven operationally. But there are a few drawbacks to it, like it requires regular backporting of patches to the multiple supported hypervisors or the multiple running hypervisors in the fleet. There's some effort required for, depending on the patch complexity, like if there are data structure changes and so on, that makes live patching slightly difficult. And of course, this is recurring work for every patch that we have to apply. Live migration is also similar, but it's slightly indeterministic in the sense this is quite heavily guest workload dependent, and not all device models support live migration. So adding LiveUpdate is an additional tool. It gives us the extra flexibility to choose the right tool for the time, for the kind of the issue that we are trying to fix. Right, so a little bit more on LiveUpdate and what our current scope is and how we are approaching the problem. We're currently only thinking about updating to minor versions. So for example, going from 4.11.1 to 4.11.2, not really thinking about major version updates just right now, but we're being mindful about those problems. But to get this working, this is what we're going to focus on. Also just considering hypervisor updates, not DOM0 or user space updates. Those can happen separately. And most of this talk is really, I mean, most of this work hasn't even begun. So we're just discussing here the early design ideas that we have and the prototyping work that we've been doing. So given this, let's look at some of the terminology that will help the future slides and the design. There's a running Xen and a target Xen. Running Xen is the Xen that's currently executing on the system. Target Xen is the Xen that we want to get running on the system. So source and target, but just slightly different terminology. And the general idea over here is to load a target Xen image in memory, initiate a live update operation, which involves pausing all the domains, masking interrupts for the IRQ lines, serializing domain states, serializing Xen state, jumping to the target Xen binary, and then target Xen takes over execution and undoes the earlier work, which is deserializing state, unpausing the domains, and going about its usual work. So let's, loading and jumping go together. So let's look at that idea first, and then we go over the rest, and specifically the loading part here. So we already have a nice mechanism to load and jump to a new Xen binary, which is Kayexact, via Kayexact. We can set up a crash kernel area, load the Xen binary in there, and pass on control to Xen. This already works in some kind of a way with current Xen, but it's an involved way. There's a series of commands that we have to run, which is unzip the binary, make it dynamically reloadable, because regular ELF binaries do not work, and specify a memory region that you want to load it into. And really, this is the first thing that we looked at. We already have worked on some of these problems. Some of our patches have already been merged. Varad, my colleague, has sent out 2 patches which are merged for the upcoming 2020 release of Kayexact Tools, which adds multi-boot support, which gives us relocation support. And we can also directly use the ELF binary. So the tricks with reloading is not required. And let's look at the other part of Kayexact, which is to jump to target Xen and target Xen taking over. This operation needs a new hypercall. It cannot really just be a simple Kayexact-E execution. And this is mainly because this operation needs to be atomic with pausing of DOM0 and passing on control to the new hypervisor. And we also need to do some other tricks in the target Xen binary. For example, Xen today would try to boot up, relocate itself, and do the usual startup things. We would really like to avoid that in the target Xen binary. So not dropping to real mode for now. This is an outstanding patch from David, which is on the mailing list, and skipping startup. So all the other work is still pending, but we are taking pokes at some of the areas over here. And to the target Xen, it needs to also accept previous state, the serialized state from the currently running Xen binary, which is possible in a couple of ways. We could craft a Kayexact command line, which gives a pointer to memory locations where this serialized state exists, or we can create a new multi-boot module. This is still an open design item. And then the target Xen needs to deserialize the state and go about doing its work after. Okay, let's look at the other parts of the problem. To pause the domain, serialize and deserialize the current state. And we already have a nicely fitting mechanism for this as well, which is live migration. For live migration, and we could easily use the live migration infrastructure because at least in minor versions, we don't expect any state changes. Some might sneak in, but it should be a problem that we can easily work around. And we really use live migration on the same machine. We don't go across machines in this case, but we switch the hypervisors while maintaining the state on the same running host. So all we have to do is change the current workflow to actually persist all memory in the host, persist all the domain structures as well, and pass on this state information somehow to the new target Xen binary. Some of the state information is mentioned here, but there's going to be more that we find as we go along. And that's also some input that we would like during this conference. There's also some host state that will need to be persisted along with the domains. IOMMU, we would have to keep it running so that DMA accesses continue working. We are going to mask interrupts, so the domains would not be woken up, but DMA needs to work. And the memory regions that are in use by domains, we cannot really trample over them. So we need to identify these regions first, and then let the new target Xen know what these regions are so that it doesn't start overwriting over these regions. And of course, relocate the target Xen binary to where it needs to be for execution later. So, I mean, it's a lot of work. This may sound too high level, but we know there's a lot of work involved, of course. We've taken some steps at prototyping, preserving the guest state. So what we've started with is preserving the state of a PV guest because we eventually want to persist DOM0 first, and DOM0 currently being PV, that's where we start from. So we modify the Excel save restore functionality right now. Excel save, what it does is it copies all the state information as well as memory onto disk. That's slightly different from what we want to do. So we are instrumenting those calls to persist the memory and currently destroy the domain, eventually not destroy the domain, but currently we let it destroy the domain, and immediately after that operation succeeds, immediately create another domain which should start working from where it was, which is just proving that we can create a domain with pre-existing structure, pre-existing state, which is stored somewhere in a well-known location. Once we have this running, we can extend this to preserving the state across a Kayexact. And so essentially, these are development milestones. This is how we are working towards it. We pointed to the Jira board yesterday on Xen. We are happy to set up the accounts there. I've already spoken with Lars. He's helping us with that. We're going to put all these items in the Jira board and continue working upstream. Eventually, then we also want to have HVM domains preserved and across Kayexact as well. All right, so this is mainly the high-level overview of how we are approaching the problem and how we are slicing it to make it tractable. There's a few gotchas that we need to be aware of. I mean, there's going to be several problems that we have to take care of and challenges. One is the pause time. What is a reasonable pause time for guests, which really sets an SLA for the live update activity, as it were. And we are targeting a few seconds for now, but eventually we would really like to have guests not notice it. And one reasonable estimate for that is not having guest network connections timeout. So 3 TCP round trip time could be a reasonable enough approximation. We don't know yet, we'll find out. And skipping a whole bunch of startup in the target Xen, not touching memory areas and so on, help with lowering the time it takes for a new Xen to come up and go about doing its work. And while the domains are paused, while the Xen transfer activity is happening, interrupts from devices could get lost. We may have to queue them somehow, pass on to the domains after target Xen has taken over. Also, something about domain states. Once we have transferred control to target Xen, unpausing all domains should not really unpause a already paused domain. Minor things like these, we really need to be careful with those things. Also, the ordering of pausing and masking activities, like do we pause DOM0 first to ensure there's no control plane activity happening? That probably seems to be the right answer. Do we mask interrupts first? Do we mask interrupts later, and so on? We'll have to iterate through this and prototype this. There's more. Timekeeping. Time is always hard. The host time, the new Xen will have its own idea of what the RTC time is, and if that is off, if that is different from running Xen, that's going to lead to some problems. PV clock also may need some syncing. And then thinking about handling major version changes or data structure changes for the future, we want some of this capability, just to be mindful of how the design should evolve over there. And the last point is controlling capabilities. I mentioned enabling new features as a potential reason why we want to do this, but we cannot just advertise new features to already running guests. That confuses guests, and it's a change at runtime for guests. We do not want that, but we want these new features to be enabled during launch. And currently, the features are very spread out. The way Xen specifies what the configuration of a host is going to be. For example, things like, is vAPIC exposed to guests? It's a Xen command line option, so you either have it on the system or you don't. We would really like this to be a per domain configuration. And there are many such items. There's also some options which are global only, and some are domain local only, and so on. So we'd really like to get them all into launch time config options to make this much more manageable. All right, that's almost all of what I had in slides. There's we have a design session proposed, which likely is going to be tomorrow. I encourage you to join us over there to discuss ideas. Of course, we are already discussing these ideas on the IRC and the development mailing list. You've probably seen patches from us. I have put up a wiki page. It's not fully populated yet, but what we are going to do is have regular status updates over there, use the Jira board as well, and have all the patches in a Git tree in a reasonably assembled form. Cool. So that's all I had. Time for questions. Yeah. So the question is, why are structure changes problematic, and can we not reuse vCPU structures? I see. So do we want to reuse the structures, or do we want to create them new? Some structures we would reuse. For example, the ones which are based on hardware. Hardware doesn't change, and we can just reuse those. Some are which are Xen internal. We will have to recreate and then fill them with reasonable starting values.
So the principle here is basically not getting rid of power, right? So instead of live migration from one machine to another, it's live migration over time. And there is an ABI for live migration state. And that is at least the principle of the design is that is all we really want to be passing from one Xen to the next. So internal data structures, vCPU, etc., no. We are recreating the domain in the new Xen. So essentially we are expanding guest transparent live migration, for which patches will be posted soon, to also include sort of essentially a pointer to the root of the page tables to have the memory which is currently present, resident, rather than live migration normally which manually copies it across. And that is what we pass to the new Xen. Yeah? So that the domain state is all done in the existing ABI for live migration. And the design principle is that we don't actually want any of the Xen internal state. We want to be able to just boot a new Xen and run on it. And you wouldn't be transferring Xen state from one machine to another when you're doing normal live migration, so why should you be doing that on live update? We want a clean slate for the new Xen. But to make the new Xen boot faster, there are some things we don't actually want to reinitialize. We don't want to have to go and spend time resyncing and calibrating clocks. We definitely don't want to reset the IOMMU. So we will also pass over eventually some hardware state to the new Xen to bypass some initialization. And obviously for IOMMU, for pass-through devices, we're not doing that yet. We're doing pure PV guests to start with. But when we get to the point of pass-through devices, we are going to have to leave the IOMMU running. You cannot pause the guests and give them DM. You cannot pause the devices and give them DMA faults. So that has to keep running. And then, yes, we've got lost interrupts and reinjection to deal with. We have a handle on that. We know what to expect there. But yeah, in answer to your question, no, we do not want to pass over any internal structures. That can change between versions, and we do want to be able to update from one version to the next major version, and the fun part there will be ABIs and DOM0 tool stack. But yes, we'll cross that bridge when we come to it.
Yeah, when you come to HVM domains, obviously transferring the live emulation state of an in-flight I/O or something like that's going to potentially be tricky. That's very much a Xen internal structure, which is shared then with the emulator. It's stable at least, but you're going to have to somehow transfer that in-flight I/O state from one Xen to another.
That's guest transparent live migration.
Yes, I suppose it is. Yeah.
Yeah.
I was thinking that would be PV only, PV protocol only. But yes, you're going to have to do that with emulated as well.
Yep. We've got guest transparent live migration for HVM. We have to save a lot more state than is currently done for suspend resume, and that's there are patches for that. They will be visible shortly.
Okay, cool.
What's next?
So another question would be, how do you live migrate DOM0 without DOM0 being active? So normally the migration stream is received on DOM0 and then by hypercall the new domain is created. But when you have no DOM0 running, this is kind of a chicken and egg problem, right?
Indeed, yes. So the idea is that instead of passing a multi-boot module to the new Xen, which is the Z image of the new DOM0 to be booted, we are basically passing the live migration state blob to the new Xen as a multi-boot module or a pointer on the command line or something, but the way we're looking at it at the moment is probably a multi-boot module. And then, yes, the new Xen, instead of starting up a new kernel as DOM0, it will resume that state. So what we're working on with the prototype that Amit talked about was doing that serialize and deserialize of a PV domain, because this is what we want it to do for DOM0, within one running Xen. So just serialize the state and leak the page tables for now, and then deserialize and create that new domain from the state and by taking ownership of those pages. And then, of course, what we really need to do that is split that across Kayexact. So serialize once, and you can leave it paused. You don't have to destroy it then. Kayexact into the new Xen and deserialize that state to recreate your shiny new PV domain from the state you were given. And then, yes, you do this for DOM0, and you pass that state as the multi-boot module across Kayexact, and all the pieces of the jigsaw eventually fit together, and you have it working, right? So our next milestone will be doing this with just a PV DOM0 running, and then we'll look at how to resume the actual DOM-Us. And one option is that all the state of those DOM-Us will be stored in DOM0, and it will be DOM0 which then restores those DOM-Us. But the problem with that is that we don't want Xen using the memory that belongs to those DOM-Us before we've had a chance to say, oh, actually, we need that page. So there is some merit in having Xen do them all. Given that Xen is going to have the code for deserializing DOM0, because what else is going to do it, maybe we end up having Xen redo all the domains rather than letting DOM0 control that. It also reduces the latency, the visible pause time. So we're probably going to end up with Xen actually taking the state blob for all running domains and deserializing them all for itself. But we haven't quite finalized that. Yeah, we'll see when we get there, yeah?
When you say that you save the domains, do you actually trigger a suspension inside of the domain?
No, it's guest
we do?
transparent live migration.
The guest is not aware that it's doing a live migration, basically.
Indeed.
And then I also wanted to ask about the interrupt, and you said that you could queue the interrupts or something like that, but if it's MSI or MSIX, it's edge triggers, so I'm not sure
So then you sometimes have to spuriously inject them just in case.
Yeah.
Yeah. It's
Okay.
horrible, but it works. Don't ask me how I know.
Yeah.
Okay. So you had said that there's a pause for the guests during that. How does that compare to a live migrate? And let's just assume like same cab, they're right next to each other, Ethernet cables cross-plugged.
Live migrate will have to migrate all the memory pages over the Ethernet cable.
Yeah.
It will have to worry about the instance local storage if there is any. It will have to ensure device pass-through, etc. is handled.
Yeah, but I mean that's assuming you have live migrate. There's a you said on one of the slides you had mentioned that there is a slight
Pause.
Pause to the guest. How does that pause compare to live migrate? Have you looked at how that pause compares to a live migration?
I see. Yeah. Well, no. So we don't have anything working yet. So we cannot comment on what we actually see. So this is all still being actively developed right now.
Sure.
But the intent is it should be faster to live update, right? I mean, there's nothing that physically needs to be transported from one machine to another. In theory, it could be instant, but obviously, it's going to have to do something. We aspire to a world in which we can actually live update while guests are running. Now, imagine a world where you have secret hiding, and you've done it by cutting down the part where you VM launch when you go into the guest so that nothing of the hypervisor address space is visible when before you switch into the guest. And then a VM exit and the full flush is going to be quite heavyweight. So you look at the things that are done often, instruction emulation, interrupt injection, stuff like that, and you move those and you design data structures where only the minimal part has to be available in the core run loop, and you've essentially got a minimal hypervisor that handles the common case of VM exits running in its own address space, and it has to thunk back into the main Xen in order to do anything more heavyweight. And so why don't you just leave that running while the main Xen Kayexacts, and then you don't even get any pause time at all. But that's after we get the basic stuff working. Let's do one thing at a time, right? But yes, well, there is kind of a vision that ties up the secret hiding and this and gets us to a point where you can mostly have zero downtime live update. But we've got a way to go before we get there.
Any other questions? right?
Oh,
Yeah, I'd like to come back to basically what Jürgen has already started about while you said you don't...
Can you please repeat? I did not.
Better? I wanted to get back to what Jürgen has started about and where you said for domain-specific structures you don't want to migrate. Nevertheless, on the second of the things to watch for pages, you had specifically called out that you think about static annotations, compile time warnings. So there must be structures where you are concerned that you will need to migrate them directly. And the second part of the question sort of related to that is when you think about a 1 to 2 second time gap between the old and the new state for guests. Generally, when the new Xen comes up, no matter that you don't want to scrub memory, for example, it'll scale by memory size, how long it takes for the Xen to come up. But I think such a transfer should ideally be as independent of memory size as possible.
Sure. Yeah.
So what is the plan for migrating memory state in that regard?
So let me answer the first one first, which is the compile time warnings. That's just an anticipation. We don't know whether we will actually need that. But we should be mindful that if there are some data structure changes that happen, and if we don't want to be in a situation where we create some new data structures on the target Xen, and they start with initial default values, which end up as bug fixes or worse, as bugs or worse. So we really want to know which fields differ. Data types can change, or new fields can get added to structures and so on. We really want to know these things are happening and then make a call that these are either okay or handle them in some way.
But wouldn't this require prior knowledge of what is going to change? I mean, the annotation is not going to be very helpful if it only appears after the fact.
So, yeah, I mean, we know that we are not in a state to start a live update operation today. If we add these annotations to, let's say, the 4.13 code base, we can move from 4.13 to 4.13.1, knowing that we will be able to handle it. Alternatively, when the 4.13.1 live update is about to go out, we can go back to the 4.13 source code and actually compare what is happening. I mean, when a live update operation starts, we can actually do that. David had some more.
I confess I don't know what we're talking about. Live migration from one Xen to another does not depend on internal data structures of Xen. There is an ABI for live migration, and the guest state is described in that. And why would it matter? What are we talking about?
I'm not talking about guest state. I'm talking about Xen state.
But I don't care about Xen state. This is a different Xen. If we're live migrating from one machine to another, why would we talk about internal Xen state? There is domain state, and that is all that matters. And if we're live migrating in the dimension of time instead of space, that doesn't change.
I mean, as you said, you need to transfer page ownership, for example.
Yeah.
So you need to communicate what page is owned by what domain. And you need to do this,
yes,
as you said yourself, ahead of time, because the new Xen must not stamp across whatever is being used by any domain actively. So
yes,
page allocation state is effectively something that needs to move from the old to the new Xen.
Yes.
The specific case of those pages which are owned by domains, yes. So the plan at the moment, which will evolve over time, is that we are starting up in the crash dump area, and at early boot, we will have a Xen heap from those pages, which we know don't belong to any domains, right? And so this is one of the reasons I mentioned we might actually resume all the DOM-Us early from Xen before transferring control back to DOM0, because we need to have worked out where all those pages are before we are in normal running operation. Yeah. So One way to do that is actually walking the page tables. If the live migration state contains a pointer to the root of the page tables, you can then walk them. That might not be very fast. We might do it with a bitmap or range list or something. So yes, we will have to pass, at the very least, the page list. We will have to mark which pages are used by domains. And if we have a separate data structure for that, rather than simply inferring it from the domain state, then that can be processed at very early startup, and then DOM0 can be responsible for actually resuming the DOM use. So yes, that part does have to be transferred from one Xen to the other, but that's not data structures, that's just which pages are owned by the domains, which pages can you not use, right? So I'm really trying to avoid thinking about having to transfer Xen state, and I'm pushing back on Amit and others every time we talk about it, which is why I'm pushing back when you say it as well. I want to transfer hardware state, and I want to transfer domain state, but internal Xen state should be a clean slate for the new Xen, yeah? Is the design principle, and yeah, details and reality are going to get in the way, but I want to start that way, yes?
May I suggest, because we sort of moved into the design session kind of already, that we have a break and discuss all the sort of detail in the session?
Sure, yeah, please come to the design session tomorrow.
Actually, I'm a little bit confused because there are about two. So one is about live patching and one is about this, and the schedule currently shows this tonight. Not tonight, at the end of the day.
Okay.
I'm going to run the scheduler again in a while, but actually it might be best to just lock that one at that time today. Is that okay?
That is
and then
Today's
also,
fine. Yeah.
Last time I looked, it was end of tomorrow. Is it end of today now?
end of today.
End of today now. Today is fine. Yeah.
And also just while you're still all there, we have more design sessions than we have space originally, but we have the capability to split this room. So tomorrow we're going to split this room into two parts to get more space and be able to do more sessions in parallel. All right. So thank you.
All right. Thank you.